Okay, thank you, Louis. Thanks everybody for joining. I hope you can see my screen and my presentation.
We can.
Yeah, okay, thank you. So I will be presenting, as we said, FIESTA ontology, and I guess everybody knows about what FIESTA is and what it offers. So I will not actually go into details of that, but I will just talk about what tools and what we have done with respect to FIESTA ontology. So FIESTA ontology is basically generated keeping the FIESTA objectives in mind and the requirements coming from already existing testbeds. So in case as a testbed provider you have other requirements, you can contact us and we will try to add the requirements and make it useful for your testbed. This is something I will present and as a template in the later part of the presentation. So what is FIESTA ontology? FIESTA ontology has like basically reuses concepts from different ontology. No new concept has been created. All the concepts that are there, all the classes that are there are actually coming from existing ontologies. The core of FIESTA ontology is basically coming from SSN ontology and IoT Lite ontology, which also uses QU, but the core properties and concepts are coming from SSN and IoT Lite. So these concepts are like the device, the sensor, the deployment, the platform, services. All these are actually coming from SSN and IoT Lite. Because SSN and IoT Lite and other ontologies that we have used use many concepts, we have pruned the concepts or the ontologies to whatever our needs is. So basically we are not using all the concepts from SSN, we are not using all the concepts from IoT Lite, and it's like that. So it's basically merging various ontologies, but in a lightweight fashion. Not exactly lightweight, but lightweight fashion. The ontology, of course, is observation oriented. So SSN and IoT Lite basically with the core concepts that are here, we tend to record or address the description of the resource or the sensor or the device that is producing the observation and the observation itself. So other than SSN and IoT Lite, we have geo ontology. We have integrated geo ontology. Some concepts from geo, basically for location aspects. This location is related to or provided to the resource or the sensor observation and entities. Then we also integrated some concepts from DUL and time for the observation part. For the taxonomy that we have used, basically for homogenizing and giving federated, basically integrating different testbeds for different testbeds, is coming from, the taxonomy is coming from M3 Lite. This is the light version of M3 ontology, specifically created for this project. So yeah, M3 Lite actually provides taxonomy for sensor, for quantity kinds, for units, and for domain of interest. So and of course related concepts to those four. So this is the core. Then the main ontology, and then we also have integrated 1M to M as equivalent concept. So we have for some concepts that are there in 1M to M, we have used equivalent classes. So as to ease testbeds that are using 1M to M ontology to integrate. Okay, so this is the whole picture of FIESTA ontology. This is basically divided into two parts. I will speak about those two parts. One is the resource part, which is the description, and one is the observation. This ontology actually also has links different concepts using properties, data properties, and object properties, which are shown here, and has cardinality restrictions. So, like a device can have multiple domain of interest, and similarly, a sensor can have made multiple observations, but an observation can only be made by one sensor. So those types of restrictions are also there. I will speak about what are the best practices also in order for the testbeds to actually provide data so that it is useful. And this is where I will speak about how to push data. So going a little bit more into details of some of the concepts that here. Of course, I will not talk about all of them. One of them is the deployment, which is basically the testbed name from where the resource is. So basically, this is just the name which describes from where the resource is and the observations that are produced. So we have this deployment concept which just stores the name. Then the main one is the device, which has subclasses like sensing device and sensor, or the other way around, sorry. It's the sensing device is a subclass of device, and then sensor is a subclass of sensing device. So basically M3 Lite provides the taxonomy for these this sensing device, and then whatever sensors you have, you can choose from M3 Lite taxonomy, and if there is something missing, just let us know. We will try to integrate it. So yeah, then there's quantity kind, which is the phenomena that a sensor senses, just the environmental phenomena or whatever phenomena is there is defined by quantity kind, and the unit of measurement. Then okay, for observation part, we have the time of when the observation was made and the value. We consider each observation to be instantaneous. Currently we do not consider streams or over a period of time. So we consider each observation to be instantaneous. If you want to push a data observation which was taken over a period of time, you can just average the data value that was observed and just put the average time instant there. So basically this is the whole ontology, which is, as said, divided into two. So next one is the resource part. So in the resource graph, we have these concepts, basically those concepts which actually describe this device or resource. Note that we also have this metadata here. This is basically a metadata by definition. You can look at this like that, which basically doesn't have any domain, so you can attach it to any concept, whichever you feel like, and you can reuse it as you want. Just do not abuse it. So yeah. So this is the resource part. For observations, we have the following structure, following graph, which is basically the instant, the observation, the time instant, the observation value, and the location where the observation was taken. Okay. For M3 Lite taxonomy, as I said before, M3 Lite taxonomy provides basically the taxonomy for sensing device, quantity kind, units, and domain of interest. Some of them we have already defined, so the subclasses for those sensing devices basically are the taxonomy that we have provided. If you find something missing, as said, let us know, we will add it. I'm not going into details of each of them. The documentation is available ontology document on the web and in the Moodle, so we can go through and know what these concepts are. So yeah, this is said for sensing device, quantity kind, units, and domain of interest. So this is basically one resource graph that is coming from the Sound City testbed that we have here in NVIDIA. So we have a device which is basically has a deployment. Sound City testbed is associated to a platform and has a domain of interest. We have multiple domain of interest, but I am only listing one here. Then this device has for us in Sound City, we have a device can have 4 sensors. I'm only listing one here, which is the sound sensor. So this device has subsystem, which is sound sensor, and the sound sensor basically has quantity kind sound and detects noise basically, and has a unit of decibel A. This platform currently has a geopoint also or the location. Going into the observation aspects, as the sensor basically made an observation, and an observation is observed by, so we keep both the links so as to link both the graphs. For us, there is an observation which has an observation result, which is basically the sensor output, the observation value, and the unit. For sound, we also have what was the sensing type. Basically, it was automatic or manual or calibration. So all those things are also there because this is coming from mobile phones. So we have that, and then the source also, which basically relates to what is the source of the noise. It can be a train or a police car passing by or an ambulance passing by. So it can be a siren. It can be all those things. Then there is also the time instant when the observation was taken and the location. So best practices to publish data so that it is useful and can be used by experimenters. We have some best practices where we say, okay, please do not have any blank nodes. Create individual for all the concepts. Have meaningful URIs. Respect the cardinality and do not push unnecessarily fake in test data. This is where I think Benjuan will be speaking to you about the validation service that we have and the certification portal. So I'm not going into details of that. Coming back, so basically do not push any fake in test data and remove unused concepts that are not used by you. Then, as I said, the link between resource and the observation graph is basically coming from the sensing device, so or the sensor. So please respect that URIs and make it identical in both resource and observation graphs so that they can be queried. And in the observation realm, have both made observation and observed by links. This is useful in the case of mobility or when you want to understand if or to get what is the recent location of the sensor or of the device. In order to get that, basically you have to query the observation graph So it's best that you provide both made observation and observed by link. And of course, do not abuse metadata. So this is a sample query. I don't think so you will be more interested into this, but I just kept it in case in order to query the data that will be there or to use ontology, we have this Sparkle query here. This is the Sparkle query I'm using for one of my experiments. And basically here I'm using the sound and the sound sensor, getting the recent value of the location and the time or the most recent observation that was made by the sensor, and basically making it a large scale. So running it on all the devices that are there. Some resources. This ontology, the FIESTA ontology, is already there on Love for IoT. It's under discussion for Love. There is a document available, like the FIESTA-IoT.html. It links. It's the web version of the ontology. It's there for M3 Lite. It's also there. And then for the playground, it's the IoT registry and the APIs. Then there is this paper also available that you can read. Okay. For the update process, we have provided, we provide the template. We basically have, you can request us to update two things. One is the taxonomy and the ontology, and both of them follow a different structure. I guess most of the updates will be in the taxonomy. So if you have any updates or requests to be made, please follow them, and please provide the name that you suggest, the comment, the label, the superclass if any, the defined by if it's coming from existing ontology, and the justification for addition. And of course, if you find any other issues, please let us know. For ontology, it's a bit different. So because we do not follow or do not create any new ontology, so you have to actually tell us what is the source of the new concept, basically the ontology, description, the domain and the range, the cardinality, the object properties, and similarly for the data properties, and of course the justification for addition. Okay. We because it's a short period, we would like to stick with this timeline. So it would be great if you guys can make requests for updates until 7th of April, and then we will reply to you by 21st, then until 22nd and 28th. Until 28th, it will be an open discussion to you guys and between us and you guys. On the 2nd of May, we intend to release the new ontology, and this is where you can use them in your annotators. Okay, so that's all from my side. Questions?
Okay, thank you,
Yeah.
Rachid. I think that, I mean, besides understanding the ontology, that I mean, we reckon that that it would need a little bit more of time from your side, and what although Rachid has.
Could you speak up, please?
Yes, I mean, sorry, I mean, always with my. I was saying that I mean, we reckon that consuming this information will require some time from you, and let's say the ontology might not be the let's say the best reading you can find, but I think that critical issue is this last thing that that Rachid has mentioned about the update on the ontology. We have created mainly the taxonomy, thinking on, let's say, not only the quantity kinds and let's say the phenomena and the units that we had in our testbeds, but for, let's say, for larger community, but maybe this is, let's say, we haven't achieved it for your specific details on your infrastructure. And then it's very important that you can go through the taxonomy and look for let's say for the individuals, let's say for the classes in this case of quantity kinds related to the phenomena that your devices can monitor, and also the units in case you don't find it, you will need to place this request for update, and then we will implement it and let's say publish the updated version of the taxonomy. With the ontology, it's as Rashid has said, it's a different issue, but still, let's say it's possible to make this update. Okay, so let's say not going